October 15th, 2021 live stream math tutoring session with Math Celebrity. We're going to run through a few problems here live and work out the solutions. So first in our stack of problems today, a student asked the quotient of the sum of 17 and x and y. So if you take a quick or closer look at this, we've got two parts, the sum of 17 and x and the quotient of that piece and y. So let's do this by parts. 17 and x, and we add x to 17. 17 plus x. Quotient of, just whole statement here, and we divide 17 plus x by y. So we put the parentheses around this because we're dividing the whole term. Plus x divided by y. So that is our first algebraic expressions problem today. Save that and we'll go to the next one. All right, so the next one is, this is a biggie. You work for a remote manufacturing plant and have been asked to provide some data about the cost of specific amounts of remote. Each remote R costs $3 to make, in addition to $2,000 for labor. Write an expression to represent the total cost of manufacturing a remote. Then use the expression to answer the following question. What is the cost of producing 2,000 remote controls? So we've got two questions here. Question one, we want the cost function, C of R, where R is the number of remotes. C of R equals variable cost per unit times R units plus fixed cost labor. In this case, it's a labor cost. C of R equals, it costs $3 per unit to make, and we said we're going to do R for each remote, and then a fixed cost labor of 2,000. So we've seen that here. $3 is our variable cost per unit, R remotes plus $2,000 in labor. So this is our first answer. This is our cost function, C of R. So question two, what is the cost of producing 2,000 remote controls? In this case, R equals 2,000, so we want C of 2,000. C of 2,000 equals 3 times 2,000 plus 2,000 from this equation. C of 2,000 equals 6,000 plus 2,000. And C of 2,000 is going to be $8,000. So we had two parts. First, we want the cost function. And then we want to know what the cost function value is for a certain amount of remotes. In this case, R equal to 2,000. So that's how we knock out those two problems in one. All right, let's move on. Let's go to, this is a good one. We get these a lot in algebra. Let's just make sure that the chat, all right, very good. Okay, so we got Gina earned $68.75 for 5 hours of tutoring. How much did she earn per minute? The first clue of this problem is the problem states the earning per hours, but they want the earning per minute. So we say 5 hours equals 60 minutes per hour. So we say 1 hour, 60 minutes. Sorry, let's start over. 1 hour equals 60 minutes. 5 hours equals 60 times 5. 5 hours equals 300 minutes. Now we have the earnings in terms of minute. So we have $68.75 divided by 300 minutes to get our earnings per minute. So I'm going to go over here in another window where you could use your calculator if you want. 68.75 divided by 300. 23 cents approximately. So we got 23 cents per minute is our final answer. So there was two parts here. First, the time units were different, so we had to get them matching. And then secondly, the cost per minute is just the total cost divided by the total number of minutes. So, and I want to put that here. Total cost per minute equals earnings divided by total minutes. So that's our cost. This is actually a unit cost. So that's how that problem is solved. Let's move on because we've got a couple more on our list. Let's see what we got here. All right, this is a good one. Another one that pops up all the time on pre-algebra. So we've got Jill made 122 muffins. She put them into 3 boxes and has 2 muffins left. How many are in each box if they all contain the same amount of muffins? So I like to start by declaring variables for what we want to know. Let B equal the number of boxes. We're told that, or no, I'm sorry. There's 3 boxes. B equal the number of muffins per box. So let's switch that up. M equal number of muffins per box. We're told that we have 3 boxes and 2 muffins left after filling up all 3 boxes. So we've got 3 boxes times M muffins per box plus 2 left over equals 122. Now, instead of jumping off the window and using our automated calculator, let's just do this manually. So subtract, to solve for M, we subtract 2 from each side. 3M plus 2 minus 2 equals 122 minus 2. Cancel the 2's on the left side, and we get 3M equals 120. Divide each side by 3 to isolate M. M over 3 equals 120 over 3. Cancel the 3's on the left side, and we get M equal to 40. So that's it. It was just a matter of writing this out as quantity equals amount per box times number of boxes. Add on the leftover and you get your total. So we'll put equation, and that one is done. All right, moving on. Here is another one, consecutive integers. So you'll see this in pre-algebra and algebra. Problem reads 4 consecutive integers such that the sum of the first 3 integers is equal to the 4th. So let n be our first consecutive integer. So we've got n. Our next consecutive integer is n plus 1, then n plus 2, n plus 3. So these are our 4 consecutive integers. We don't know what n is, but we know we can pick n or x or whatever we want to represent our first one. And we're told, let's see, 4 consecutive integers such that the sum of the first 3 integers is equal to the 4th. Okay. So the sum of the first 3 integers is equal to the 4th. So we have n plus 1 plus n plus 2 equals n plus 3. So these are the sum of the first three, and we're told it's equal to the fourth. So simplify by grouping like terms. We've got n plus n plus n plus 1 plus 2 equals n plus 3. Gives us 3n plus 3 equals n plus 3. Now, just looking at this, the threes, if we subtract 3 from each side, they cancel each other out. So what we have is 3n equal n. And we see that if we divide by n, this is impossible. So whoever typed this either didn't supply more info or didn't realize that there's no solution to this. So we've got 3n plus 3 equals n plus 3. 2n is 0. I guess 0. No. I'm sorry. I stand corrected. So we got 3n plus 3, 3nn. And then if we, the only number that, or integer that suffices this equation is 0. So n equal to 0. Because 3 times 0 is 0. So if we have that, then if n equals 0, n plus 1 equals 1, n plus 2 equals 2, and n plus 3 equals 3. Is it true that the sum of the first three equal the fourth? Well, 0, check our work. 0 plus 1 plus 2, does it equal 3? 3 does, in fact, equal 3. So that's perfect. So here, our final answer is 0, 1, 2, 3. Perfect. So I'll put consecutive integers, and that one is done. All right, let's move on here. This one was kind of, it looks like a trick question, and some people were confused. They're like, can it be this easy? So it reads, Sheila's father is 35 years old. Her grandfather, let's spell that one right. Her grandfather is 62 years old. How old will Sheila's father be in 12 years' time? Well, if we're given her grandfather's age and we're given how many years from now we want to know the age, we don't care about this. So this is a helpful trick in math to cancel out or ignore extraneous or useless information. So let's look at what we care about. Grandfather today is 62. Okay, so in 12 years' time, grandfather will be 62 plus 12, which is 74, and that is it. So some people get confused by Sheila because they're asking, well, where does Sheila come in? And they don't care. Unless they mean, okay, so they put Sheila's father, but Sheila's father's age is not given. So I've seen this written as Sheila's grandfather. So this is kind of confusing the way this is written because there's no age given for the father. So I actually ignore 74 because she didn't put grandfather. So I'm gonna cancel this problem because it doesn't make sense. Let's go to another one. So here's a good one. Another algebraic expression. Let's try that. All right, so 2 more than twice the sum of 10 and a number. So the sum of 10 and actually let's start even earlier than that. The phrase a number means an arbitrary variable. Let's call it x. Start with x. Let's get rid of this. Algebraic expressions. Arbitrary variable. Okay. The sum of 10 and a number means we add x to 10. 10 plus x. Twice the sum means we multiply 10 plus x by 2. We got 2, 10 plus x. 2 more than twice the sum means we add 2 to this. We got this plus 2. And that's our answer. So as you can see, there's 4 parts. Some students and parents get tripped up on the phrase a number. And whenever you see a number, it's just an arbitrary variable. So you can call it X, Y, N, A, B. It doesn't matter. But a number is a vague term for pick your variable and go from there. And then we had a sum, which we built. We take twice the sum. And then finally we add 2 more than twice the sum and we are done. So that is it. All right, what else we got? We just did this one. Maybe we'll do 1 or 2 more. Let's see. Jesse bought 2 oranges and 3. I'm going to need another screen for that one. Okay, let's do this one. A lot of people want to know about financial literacy and savings and all that, so let's do this. So Karleys' bank account was negative 1214. She then deposited 2163. What was her account balance? All right. So negative 1214 can be written as negative 1214. So Karleys already starting out with an account deficit. So that means she has less than 0. She owes the bank money. And immediately when I see problems like this, my brain starts screaming, this is a signed operation problem. Or it's also called signed integer. She then deposited 2163, which means we add 2163 to her bank account balance. Or we can add 2163 plus 2163. Final account balance is got negative 1214 plus 2163. So I go off screen here because I don't have a calculator. At $9.49. The key here is this is a sign operations or signed integers. And so a deficit or a subtraction or a spend is always marked as negative. Deposits or incoming money is marked as positive, and then you list it out like this and get your final answer. So that is it. All right, what else we got? Let's do let's see what else we got. Because some of these are going to require 2 or 3 screens for math. Yeah, let's do this one and we'll shut down the stream. All right, so we got last one today. Jim and his family are touring Chicago. They want to visit the Willis Tower, hang out at Navy Pier, and shop on Michigan Avenue before their dinner reservations at 4:15 p.m. They plan to spend 1 hour and 25 minutes at the Willis Tower, 1 hour and 40 minutes at Navy Pier, and 1 hour and 40 minutes shopping. What is the latest time Jim's family can start their tour of Chicago and still make it to dinner on time? So first thing we want is how much time is Jim's family spending on pre-dinner activities? All right. So we start with 1 hour and 25 minutes at Willis Tower. Let's list these out. First thing, 1 hour and 40 minutes at Navy Pier. 1 hour and 40 minutes shopping. Add these all up and we get 3 hours right here, and then 40 plus 40 is 80, and 105 minutes. But 105 minutes gives us what? Equals 60 minutes for a full hour plus another 45 minutes. So what we get is 3 plus 1 hours equals 4 hours and 45 minutes. All right. So this is one of the tricks here if you don't know time. Anytime you get minutes above 60, you got to convert to an hour and subtract off 60. So 105 minutes is really 60 plus 45. The 60 is credited for another hour, and we're left with 45 minutes. So we got 4 hours and 45 minutes that Jim's family spends on pre-dinner activities. If they got dinner reservations at 4:15, so let's go here. If dinner reservations start at 4:15, the latest, well, let's assume that Jim ends like right outside the dinner place because we're not accounting for travel time when they're done shopping to the restaurant, which this problem doesn't tell you, but that's how this works. The latest Jim's family can start their tour is, we want to know 4:15 and go back 4 hours and 45 minutes. Well, what we could do is we go back 5 hours. So this is 4:15. I should have wrote PM. Go back 5 hours and we get 11:15 a.m. and add 15 minutes because 4 hours and 45 minutes is 15 minutes short of 5 hours to get 11:30 a.m. Now, if you don't like the 5 hours and then add more, we could just do exact time. We could say this 4:15 p.m. and go back 4 hours. All right, so we'll go back 4 hours to get 12:15 p.m. Now go back another 45 minutes and we get 15 minutes is 12 and another 30 minutes gets us to 11:30, which is 45 total minutes a.m. So either way you want to do this, some people like to do exact time, some people like to go a full hour and then swing back. But the point of it is you start, the fastest way to solve this is add up the time before dinner and then walk backwards from the dinner reservation based on the exact amount of time of the tour, and you get your answer. So that is it. And I think I'm going to end the stream here. I appreciate you watching, and I will see you